Welcome to my new video series, KmanENERGY. We have KmanAuto covering all your favorite transportation modes such as steam and electric, but now we have KmanENERGY. And in this series, I will be covering different styles of batteries and electronics and how they're constructed and how they maintain energy, so on and so on. So what we're going to be doing is, for the first video in this series, we'll be deconstructing a ever-ready 45-volt alkaline battery for old medical equipment and telecom equipment, meters and testing. But just to preview some other things that I will be disassembling and showing you the internals of. And it's not just limited to U.S. products or North American products, but things from all over the world. We have lithium battery here for medical equipment. I'll be taking apart 9-volt alkaline pile batteries. Both alkaline and the carbon zinc are pretty much the same. And then we have internals of laptop batteries, different styles of laptop batteries. We have a Dell over here. We have this one from a Lenovo. And we got another, I think this one's a HP. This one's a flat. These have round cells in them, so we'll see how those are constructed and the battery management systems on those. We have a first-gen iPod Shuffle. And while we get a little green light, it doesn't power on any longer. So we'll take it apart to see what's inside. And worst case scenario, nothing happens. Best case scenario, I might end up with a working iPod Shuffle again. Great for audiobooks. We have a power strip made by Bull, B-U-L-L. And this is from China. Chinese plug on it. And this is a 10 amp 240 or 220 volt, and the neat thing about this one is it's designed to accommodate plugs from a number of different regions and countries. We have an actual wall outlet that we'll be exploring and seeing the internal construction of, and of course, you know, with all the speak of hoverboard fires, we have actual hoverboard batteries. We have one that's still shrink wrapped, and then we have one that's already open, 20 cells. We're going to take a look at the battery management board on that one. Moving on over, we have a setup from a portable DVD player, which the specs on the DVD player and what the batteries were set up as are two extraordinarily different things. Unfortunately, I don't have the casing for it anymore. It was damaged, so I disposed of the casing. We're going to be disassembling a burned out LED light bulb. That's Sylvania, which I'll never purchase a Sylvanian LED bulb again, even with receipt and still under its warranty. Will not replace. Every excuse in the book. And there was a recall on that specific light bulb, and they still refused to replace it. So we're going to cut that open and take a look at the construction of that. We have a die-hard lithium-ion Craftsman tool battery. We'll be opening up, taking a little look at that one. And then we have an interesting one. We have two 18650 cells. I have a little tape on the end for safety. Two 18650 cells from a Tesla Model S 85 kilowatt battery pack. And I've actually had these for about a year. And I did a series of testing on them, capacity testing, to see if the advertised capacity was the same as the actual capacity and what the degradation might be after a year of sitting at a 100% charge. So that's just some of the interesting things that will be coming. Pretty much anything new that I come up with, I mean, we'll even take apart that multimeter, see what's inside. So basically anything new that I can come up with, just to see what's inside and how it works. I'm just taking a little peek. A lot of things are around. A lot of people just don't know what's inside their laptop battery. And I will show you and explain why your laptop battery goes bad, even though it might not be bad. And on top of that, I have approximately right now 1,000 18650 cells, and we will be building two different battery systems. One will be a portable jump starter to give a electric vehicle an emergency charge. It'll give you an extra 2 or 3 miles of power, enough to get you to a regular wall outlet of some sort or a higher powered charging station. And the second one is we'll be building our own Tesla style Powerwall of some sort, and or modifying it to work as a giant battery bank for my teardrop travel trailer. So that's what we have. Oh, almost forgot. We have LG phone batteries and Samsung phone batteries and a Motorola, and the construction of those are all pretty much the same. So we're going to choose one, and of course, with all the talk of Samsung battery fires, this one right here is starting to bulge. So we're going to peel the labeling off on this one. When a battery's bulging, that's when you get rid of it. So we'll destroy that one. These other ones are actually still good, and I'm going to use those in future projects. But this one's going to recycling center anyway, so we'll take a look, see if there's a if or what kind of battery management board might be inside there to keep those in check. And it seems like I am seeing Samsungs fail all over the place. Actually, these are all Samsungs too, and these particular cells are actually really, really interesting. So I'll cover that as well. So everything here will be getting its own separate video and exploring a bit what's inside and how does it work and comparing them. Like a big thing is I'm interested in the safety of these Chinese outlets to see if the construction really stands up to what they're rated for. Because I mean, especially these, I've seen these in China draped out windows of apartments hanging down at street level, no protection on them from the elements, charging up electric rickshaws and scooters. So let's just see what's inside. So anyways, welcome to KmanENERGY.